Hi to Ho students, Mr. Kaczynski with you. We're going to go through some notes for 8.4b, special product patterns. All right, so first of all, our directions for number one, use a rectangle diagram to expand a plus b squared. In other words, a plus b times a plus b. Okay, let's do a square here. Let's break it up into parts. It is a plus b wide, and it is a plus b tall. Okay. So a times a is a squared. Down here in the bottom right-hand corner, it's b tall and b wide, so b times b is b squared. This one is a tall and b wide. And this one right here is a wide and b tall. All right. So what does a plus b squared equal? In simplified terms, well, we've got that a squared. We've got ab and ab, which makes 2ab. And then we've got the b squared. So that is the square of a binomial pattern. Maybe we should write that down. All right, so we're going to use that pattern a few times to square some binomials, which we've kind of already done, and also factor some binomials. We'll talk about that when we get there. All right, so x plus 7 squared. I think I'm going to go full screen here. Expand the following expressions using the square of a binomial pattern, which is this. So it's always going to be that first term squared, the last term squared, and in the middle, double the product of the two. Double the product of the two. So this might look something like this. You take that x, that's going to get squared. You take the 7 and the x. Oops. Sorry. Let's try this again. So that x is getting squared. In the middle, we're doing double the product of the x and the 7. And at the end, we're taking that 7 and squaring it. All right, so it's just going to be x squared plus 14x plus 49. Like I said, we've done that a little bit already. So x squared is x squared. 7 squared is 49. 7 times x doubled is 14x. Let's do it again. So this time we're going to take that x, and that's going to get squared. This is subtraction, so it's actually going to be, well, we could write it like this. Plus 2 times x. And the second term is negative 3. Let's look at it like that. And then we're also going to take that negative 3 and square it. So it's going to be x squared minus 6x plus 9. Okay, and this last one, let's see if I can make myself some more room here. All right, we're going to take that first term, 3x, and we're going to square it. In the middle, we're going to double the product of the two terms, the 3x and the 4. And then on the end, we're going to take the second term and square it. All right, so 3x squared, 3x times 3x is 9x squared. And then, let's see, 3x times 4 is 12x, doubled is 24x. And 4 squared is 16. There we go. Let's see what that looks like on the tables here. Let's just check that last one. 3x plus 4 squared and 9x squared plus 24x plus 16. Tables are the same, and just one parabola shows up. So I know I've done the square of a binomial pattern correctly. All right. Now let's factor these expressions. All right. Well, maybe they fit the square of a binomial pattern. Let's find out. Like the square root of 25 is 5, and the square root of x squared is x. So this might be 5x squared, and I know 4 is a perfect square. It could be written as 2 squared. That's 4. And in the middle, maybe we've got the product of the two. Maybe it's 2 times 5x. You know what? I think it's going to be times negative 2, though. Let's throw a negative in there. So it looks, yeah, because that works, right? So it would be negative 10x doubled is 20x. All right, so yeah, I could rewrite this as 5x minus 2 squared. Let's go to the calculator and check that out. Here's the original written in standard form, or general form, 25x squared minus 20x plus 4. And then we wrote it in factored form, 5x minus 2 squared. Let's check the table. They are the same. Boom. All right, let's do it again. 4x squared is a perfect square and 1's a perfect square. That's usually a pretty good clue that it might fit the square of a binomial pattern. So the square root of 4x squared is 2x. The square root of 1 is 1. And in the middle, I'm hoping that maybe it'll fit this pattern. Double the product of those two square roots. Oops. So 2x times 1 is 2x, doubled is 4x. So this should be 2x plus 1 squared written in factored form. So we're taking expressions that are in general form and we're writing them in factored form, kind of like vertex form. Let's check that one too. 4x squared plus 4x plus 1. And we wrote it as 2x plus 1 all squared. Yep, they are the same tables. So again, I'm looking for, is this a perfect square? Is this a perfect square? Is this, the middle, double the product of those square roots? Let's keep going. All right, let's do this like this. Okay, I'm thinking 3x times 3x is 9x squared. 4y times 4y is 16y squared. If I multiply 3x times 4y, I'd get 12xy. And 12xy doubled is 24xy. And I see that subtraction sign. I'm done. That's it. X times x is x squared. 5 times 5 is 25. Here's the problem. 5 times x is 5x. 5x doubled is not 26x. So this is, let's write it like this. 2 times x times 5. That doesn't equal 26x. So this can't be right. Oops. So this can't be, oh, it says factor it, but yeah, it can't be done using this pattern. We'll get more in this one. This one is actually, what is it? X plus, can it be factored? Yeah, x plus 1 times x plus 25. 1 times 25 is 25. 1 plus 25 is 26. So that one does not fit the square of a binomial pattern. All right, let's move on. Got another pattern here. It says use a rectangle diagram to expand this. All right, so let's make this A plus B wide and A minus B tall. This is A squared, because it's A tall and A wide. This one is B wide and negative B tall, so that's a negative B squared. This one is A tall and B wide. And this one is A wide and negative B tall, so it's going to be minus AB. All right, so when we have something that fits this pattern, A plus B times A minus B, it should always equal what? Well, we've got this A squared. In the middle, AB minus AB is 0 AB. It's nothing. So these like just cancel each other out, don't they? And then minus B squared. And that is called the sum and difference pattern. The sum and difference pattern. So whenever we multiply something that's A plus B times A minus B, we'll see some examples. It's always going to turn out into A squared minus B squared. Stuff like this. So we're going to use the sum and difference pattern here. See, this is x minus 5 and x plus 5, right? So it should just be x squared minus 25. Because the 5x and the minus 5x in the middle of the rectangle diagram are going to cancel out. Let's try it. X minus 5 times x plus 5 is x squared minus 25. There we go. Same tables, same graphs. -5, +5 for the roots. Notice that. All right, let's try again. Here we've got x and plus 1/2 and x minus 1/2. That's A plus B, A minus B. A plus B, A minus B. It's always going to equal A squared minus B squared. So A squared, where x is the A, minus B squared, where B is the 1/2. And in the upper right-hand corner, and see, this is x squared. This would be minus 1/4. This would be 1/2 x and negative 1/2 x, which are just going to cancel out. And that happens every time with this sum and difference pattern. So one more time. This should be A squared minus B squared, which is 9x squared minus 16. The 12x and the negative 12x in the upper right hand and lower left hand corner, they cancel each other out. Factor these expressions. All right, let's see. Whenever I see a perfect square minus a perfect square, I'm thinking that it's going to fit the sum and difference pattern. So this is x squared minus 7 squared, isn't it? Then I can write it as x plus 7 times x minus 7. Let's check it out. X squared minus 49, x plus 7 times x minus 7. I only see one parabola show up. Let's check the table. Yep, same tables. Perfect square, perfect square. This is x squared minus 1/3 squared. So A squared minus B squared. So we're going to do A plus B times A minus B. Here we got a perfect square minus a perfect square. It's 5x squared. That would give us 25x squared. And 4 squared would give us 16. So I can rewrite this as 5x plus 4 times 5x minus 4. One more. You know what? That's not a perfect square, neither is that. But 218 are both divisible by 2. So I could factor out that greatest common factor first, and I could write it like this. 2 times 100x squared is 200x squared. 2 times negative 9 is negative 18. Then I got a perfect square minus a perfect square, so I could write this as 2 times 10x plus 3 times 10x minus 3. So that I had to factor out a GCF, greatest common factor, first. Let's see if I did it right. 200x squared minus 18. I'm going to rewrite that as 2 parentheses 10x plus 3 times 10x minus 3. Look at the tables. They are the same, so I factored this completely and correctly. Are we done? I'm done. All right. So we did the sum and difference pattern. That is a plus b times a minus b is a squared minus b squared. And we talked again about the square of a binomial pattern, which is that a plus b squared is a squared plus 2ab plus b squared. And now you're going to factor and multiply using those patterns, trying to be a shortcut. It's supposed to be fast. All right, I'm done.